Before we begin tonight, I want to ask you something the way I often do. Tell me where you're listening from tonight, what country, what city, if you'd like to share, and tell me what time it is for you right now. I like collecting these little details. Somewhere it's very late, somewhere it's almost morning, and somewhere right now, for the very first time, someone is hearing this story. Tonight's story is the biggest one we could possibly tell. Not big in the sense of loud or dramatic, quite the opposite, actually. Big in the sense of scale. Tonight, we're going to tell the story of absolutely everything, the entire universe, from its very first instant all the way to this exact moment right now, with you lying here listening. We're not going to rush through it. We're not going to throw 100 facts at you and call it a story. We're going to walk through it slowly, the way you'd walk through an old, quiet house at night, pausing in each room, letting your eyes adjust, letting the scale of things settle in gradually, rather than all at once. So get comfortable, let your breathing slow, and let's go back all the way back to before there was a back to go to at all. Before there was a before. Here's a strange thing to sit with right at the start. Almost every story we tell begins with once upon a time, implying that there was a time before the story started, a world that already existed, waiting for events to happen in it. But the story of the universe doesn't quite work that way. As far as we can tell, time itself, the very thing that lets us say before and after began, along with everything else. That's a strange idea to hold in your mind, especially late at night, when your thoughts are already starting to soften at the edges. Not just the universe was empty and then it wasn't. Something stranger. There was no before for it to be empty in. Time, space, matter, energy, all of it, as far as our best understanding goes, came into being together in the same instant. Scientists call this the Big Bang, though. I think the name itself is a little misleading and worth pausing on for a moment. It sounds explosive, violent, like something happening at a single point in a space that already existed around it. But it wasn't an explosion happening inside space. It was the beginning of space itself, everywhere, all at once, expanding outward, not into something, but simply expanding, full stop, with no outside for it to expand into. It's genuinely difficult to picture this clearly, and I don't think you should worry if it doesn't fully click into place. Even scientists who've spent their careers studying it would tell you it strains the limits of ordinary imagination. Our minds evolved to understand throwing rocks and finding food, not the birth of space-time itself. Feeling a little lost here isn't a failure, it's just an honest response to something that's genuinely almost beyond words. What we do know, with a fair amount of confidence, is that this beginning happened approximately 13.8 billion years ago. And in the smallest possible fraction of the first second, the universe was unimaginably small, unimaginably hot, and unimaginably dense. Everything that would eventually become every star, every planet, every living thing, compressed into a space far smaller than anything we could picture. And then it began to expand and cool. And in that gentle, gradual cooling over billions of years, everything else slowly became possible. The first light, for a long stretch of time after the beginning, a stretch that, compressed into human terms, would still feel impossibly long. The universe was a strange, hot, glowing place, not dark exactly, but not clear either. It was filled with a dense fog of particles, so thick that light couldn't travel freely through it. Any light that tried to move would immediately scatter, bouncing from particle to particle, the way light bounces and scatters inside a thick cloud, never quite making it through in a straight line. This lasted for what was, in cosmic terms, a relatively brief period, though it still represents hundreds of thousands of years. The universe expanding and cooling the entire time eventually reached a point where something changed. The particles that had been scattering light so effectively began to combine, forming the first simple atoms, mostly hydrogen, the simplest element there is. And in that moment, something remarkable happened. The fog cleared. For the first time since the very beginning, light was free to travel, not scattering immediately, but moving outward in straight lines across the universe uninterrupted. This moment, sometimes described almost poetically as the moment the universe became transparent, left behind a kind of fingerprint. A faint, extremely uniform glow spread evenly across the entire sky in every direction that still exists today, billions of years later. Scientists can actually detect this glow with the right instruments. The oldest light in the entire universe, stretched and faded by billions of years of cosmic expansion, but still there, still arriving. Right now, even tonight, falling gently across the earth, across you, completely invisible to your eyes, but real all the same. I find something quietly moving in that. The very first light the universe ever produced is still traveling. Even now, it never stopped. It's just been spreading out, fading, stretching for nearly 14 billion years, and some infinitesimally small fraction of it is passing through the room you're in right now as you listen to this. The long dark ages. After that first light spread out across the newly transparent universe, something unusual happened, or rather, something stopped happening for a very long time. For hundreds of millions of years, the universe existed without any new light being created at all. The hot, glowing aftermath of the beginning had faded into something cool, dim, and almost featureless, a universe filled with simple gas drifting slowly through the dark, with nothing yet bright enough or concentrated enough to shine on its own. Scientists sometimes call this stretch of time the cosmic dark ages, and I think the name fits in more than just a technical sense. Picture it, an enormous, expanding universe, full of potential, full of the raw material that would eventually become everything, and yet, for hundreds of millions of years, almost entirely dark. Patient, waiting in a sense, though waiting isn't quite the right word, since nothing in the universe at that point was capable of waiting for anything. It simply was, slowly drifting, slowly cooling, slowly, almost imperceptibly, beginning to clump together in places ever so slightly denser than others under the gentle, relentless pull of gravity. It's strange to think that the universe spent such an enormous span of time in near total darkness before anything like a star existed. We tend to think of stars as a basic, permanent feature of the universe, and in our part of the story, they have been for billions of years. But there was a time early on when there were none at all, just gas and gravity and the patient, invisible work of very slightly uneven matter slowly gathering itself together in the dark. The first stars, eventually, after hundreds of millions of years of this slow, dark gathering, the universe produced something it had never produced before, a star. Picture the process slowly, the way it actually happened, rather than as a sudden event. In certain regions where gas had gathered just slightly more densely than its surroundings, gravity continued pulling everything inward, compressing the gas further and further, the pressure and temperature at the center steadily climbing. And then At a certain point, when the pressure and heat at the very center became extreme enough, something remarkable began. The hydrogen atoms at the core started fusing together, forming helium, and in that fusion process, releasing an enormous, sustained burst of energy. A star had ignited. We believe these first stars were unlike almost any star that exists today, far larger, far hotter, far brighter, and far shorter lived, burning through their fuel in a fraction of the time a star like our own sun will take. But for the first time since the very beginning of everything, the universe had a true source of new light. Not the fading afterglow of creation itself, but light being actively, continuously produced by the simple, elegant physics of gravity and fusion. I think it's worth pausing here just to imagine it. After hundreds of millions of years of darkness, somewhere in some unremarkable patch of an early, still-forming universe, a point of light flickered into existence, and then another, and then gradually many more scattered across the darkness, slowly beginning to illuminate a universe that had, until then, never known what light, in this new and lasting sense, actually looked like. These first stars didn't just bring light, they began something else, to something essential, to everything that would eventually follow. Inside their cores, through the same processes of fusion that powered their light, these stars began forging heavier elements out of simple hydrogen and helium, carbon, oxygen, and eventually, after these stars reached the ends of their short, brilliant lives and scattered their contents back into space in enormous explosions, even heavier elements still. Every single atom in your body, heavier than hydrogen, the carbon, the oxygen, the calcium in your bones, the iron in your blood, was forged inside a star like this long before our sun, our planet, or anything resembling life existed, spread outward by the death of stars that lived and died billions of years ago, eventually gathering gradually into the very particular and very temporary arrangement of atoms that happens to be you tonight listening to this story. It's one of the strangest and most beautiful facts in all of science, and it's worth letting it settle in slowly. You are not separate from this story. You are made of it, quite literally. The calcium in your bones was forged in the heart of a star that died before our solar system existed. You are, in the most literal sense possible, old stardust, temporarily arranged into something capable of wondering about where it came from. Galaxies begin to form. As more and more stars came into being, something larger began to take shape around them. Gravity, working patiently across enormous spans of time, pulled together not just individual clumps of gas into single stars, but vast collections of stars, gas and dust, into enormous, organized structures, galaxies. Picture this the way you might picture a slow, silent dance, choreographed entirely by gravity over hundreds of millions of years. Stars drawn together, gas swirling gradually into enormous spinning disks, or graceful spiral arms, or vast rounded clusters, different shapes emerging in different regions, depending on the particular conditions of how matter had gathered. Our own galaxy, the Milky Way, the very faint, hazy band you can sometimes see stretching across a truly dark night sky, far from city lights, began forming through exactly this kind of process. Very early in the universe's history, gradually growing, merging with smaller galaxies along the way, slowly building itself into the vast, spinning structure it is today. Hundreds of billions of stars arranged in a graceful spiral, slowly rotating, taking roughly 200 million years just to complete a single full turn. 200 million years. for one rotation. The last time our galaxy completed a full turn, dinosaurs hadn't even appeared on Earth yet. I find it helpful when trying to grasp a number like that to think of it less as a fact to memorize and more as an invitation to feel something, a kind of gentle vertigo, the pleasant sort, the sort that comes from realizing just how enormous the canvas really is, against which our own lives, our own histories, even our entire species play out. In the next part of this story, we'll continue forward through time to the formation of our own sun, our own small, quiet corner of this vast galaxy, and the slow, patient process that eventually led to a small blue world and eventually to you. We'll talk about just how ordinary our star really is and why that ordinariness might be one of the most comforting facts in the entire universe. For now, though, let's just sit here for a moment in this early universe with its first scattered stars, its slowly forming galaxies, its vast, patient darkness gradually giving way to light. None of it knew yet where it was heading. It simply continued the way it always has, the way it still does right now, above you, as you drift towards sleep. Sleep well tonight. And if you happen to think before you close your eyes about the stars above you, remember that some small part of you was once part of a star too. You're not separate from the story. You never have been. Welcome back. We left off with light just beginning to fill the universe, the first stars, the first galaxies, slowly taking shape across hundreds of millions of years. Tonight, we keep moving forward through time towards something a little more familiar, toward home, a very ordinary star. By the time roughly 9 billion years had passed since the beginning of everything, meaning the universe was already 2/3 of its current age, something quiet and unremarkable happened in one fairly ordinary spiral arm of one fairly ordinary galaxy. A cloud of gas and dust drifting through space, left over from the lives and deaths of earlier generations of stars, began to collapse under its own gravity. Slowly, the way it always happens, no sudden event, just a long, patient process of matter drawing inward, growing denser, growing harder over hundreds of thousands of years. At the center of this collapsing cloud, eventually, the same process that created the very first stars happened again. Pressure and heat reached a point where hydrogen began fusing into helium, releasing energy, producing light. Our sun had formed. I want to emphasize something about our sun that I think gets lost sometimes in how we talk about it. It is not special, not in any cosmic sense. It's a fairly average star of a fairly common type, roughly midway through a fairly typical stellar lifespan. There are stars far larger, far hotter, far brighter. There are stars far smaller, far cooler, far dimmer. Our sun sits more or less in the unremarkable middle. And I think that's actually one of the most comforting facts in this entire story. Because if our sun was something rare, some unusual, special kind of star, found in only a handful of places across the entire universe, then the conditions that allowed life to exist here might be similarly rare, similarly unlikely to be repeated anywhere else. But our sun isn't rare. Stars like it exist by the billions, just within our own galaxy. Ordinary, common, the kind of star you'd expect to find in countless other corners of the universe, around countless other otherwise unremarkable points of light. I don't say this to make any claims about what does or doesn't exist elsewhere. That's not something anyone can know for certain. I say it because there's something quietly beautiful about being the product of something ordinary rather than something exceptional. It suggests that whatever happened here, whatever sequence of events eventually led to a planet, and then to life, and then to you, lying here tonight happened around a perfectly normal star, doing perfectly normal things the way countless other stars across the universe have likely done as well. A small blue world around our newly formed sun, the leftover material from its formation, gas, dust, debris, continued to swirl, gradually gathering into larger and larger clumps through the same patient, persistent action of gravity that built the stars themselves. Most of this material eventually formed the planets of our solar system, some large and gaseous, drifting in the outer reaches, others smaller, rockier, closer to the warmth of the sun. One of these smaller, rocky worlds settled into an orbit at a distance from the sun that turned out to be, by pure chance, remarkably fortunate. Not too close, where any water would simply boil away under the sun's heat. Not too far, where it would freeze solid. Close enough and warm enough for something we now consider essential. But that is, in truth, one of the rarer and more delicate balances in the universe. Liquid water able to exist, stable, on the surface of a planet for very long stretches of time. This planet, of course, was Earth. In its earliest history, Earth looked nothing like the world we know today. It was a violent, molten place, its surface a churning ocean of liquid rock, bombarded constantly by debris left over from the solar system's formation, including, according to our best current understanding, a collision with another planet-sized object so massive that the debris thrown off from that impact eventually gathered together to form our moon. I find that fact almost impossible to hold in my mind comfortably, even now. Our moon, the same moon that quietly lights up the sky tonight, that has shaped tides, calendars, and human imagination for the entirety of our history, began as debris from a planetary collision so violent that it's difficult to fully picture even with everything we know about it. And yet, somehow, from that violence, something more settled gradually emerged. Earth's surface slowly cooled. Its molten rock solidified into solid crust. Water delivered, scientists believe, partly through the slow accumulation of ice-rich material over enormous stretches of time began to collect, eventually forming oceans. A quiet, blue, rocky world orbiting an ordinary star, slowly settling into something stable enough, finally, for something else entirely new to begin. The long, patient road to life. For a very long time after Earth's surface settled into something more stable, nothing alive existed on it at all. Just rock, water, and a thin, mostly inhospitable atmosphere, very different from the air you're breathing right now. And then, at some point, and exactly how and exactly when remains one of the genuine open questions in science, studied carefully but not yet fully resolved, something changed. Some collection of simple chemical processes occurring somewhere in Earth's early oceans or along its early coastlines crossed the threshold we still don't fully understand. The threshold between non-living chemistry and the very first, simplest forms of something we would recognize as life. I want to be careful and honest here, the way I try to be throughout these stories. Exactly how this happened, the precise sequence of chemical events that first produced something capable of reproducing itself, of responding to its environment, of beginning the long, unbroken chain that eventually leads to every living thing that has ever existed, including you, is genuinely not fully known. Scientists have proposed various possibilities, tested various conditions, found various plausible pathways. But the full picture remains, in many ways, still being assembled. What we do know is that once it happened, life proved to be remarkably persistent. From that first uncertain beginning, life continued, unbroken, for billions of years through dramatic changes in Earth's climate, through ice ages that covered much of the planet, through shifts in the very atmosphere itself, through asteroid impacts severe enough to end the dominance of entire groups of creatures that had ruled the planet for tens of millions of years. Through all of it, somewhere, some form of life continued, never interrupted, never starting over from nothing. A single, unbroken thread stretching back further than almost anything else on Earth, connecting the very first simple living things to every creature alive today, including, at the very end of that long thread, you. How small, how vast, how lucky. I want to bring all of this together now, gently, the way we usually do toward the end of these stories. We've traveled tonight from the very first instant of the universe's existence, through hundreds of millions of years of darkness, through the birth of the first stars and the slow formation of galaxies, to the quiet formation of one ordinary star and one small, fortunate, rocky planet orbiting it, and finally to the long, patient, unbroken thread of life that eventually led, after billions of years, to you. It's worth pausing just for a moment to feel the scale of that. 13.8 billion years, hundreds of billions of galaxies, hundreds of billions of stars within our galaxy alone, an almost unthinkable amount of time and space and possibility, all of it eventually narrowing down through countless improbable events to this exact moment. You here now, listening to this, on this particular night, on this particular small blue planet, orbiting this particular ordinary star, I don't think the right response to that scale is to feel small in a diminishing way, though it's natural and even healthy to feel small in the sense of humbled, of quietly amazed. I think the better response, the one I hope settles over you tonight, is something closer to gratitude. Not gratitude directed at anything in particular, necessarily just a quiet, settled appreciation for how unlikely, how delicately balanced, how genuinely remarkable it is that any of this happened at all. That after 13.8 billion years of cosmic history, the universe produced something capable of looking back at itself and wondering, you are that. Right now, lying there, listening, breathing slowly, made of atoms forged inside stars that died long before our sun existed, living on a planet shaped by violence and patience in equal measure, carrying within you an unbroken thread of life stretching back billions of years. That's not a small thing. It's actually one of the largest, strangest, most improbable things that exists. A closing thought. As we close tonight's story, I want to leave you with something quieter than facts and numbers. The universe, in its 13.8 billion years of existence, has produced an almost unimaginable amount of darkness, emptiness, and silence. Most of it, by far, is empty space, vast, cold, quiet distances between scattered points of light. Against that overwhelming backdrop, the existence of anything at all, a star, a planet, a single living cell, is already remarkable. And the existence of something capable of awareness, of wondering about its own existence, of feeling curiosity, of choosing tonight to listen to a story about where it came from before drifting off to sleep is rarer still. As far as we currently know, vanishingly rare. Perhaps even, for all we can say with certainty, entirely unique to this one small, fortunate planet. I find that thought both humbling and, in its own quiet way, deeply comforting. Whatever else is true about the size and age and silence of the universe, you are here, thinking, feeling, wondering. For this one brief, improbable stretch of time, in the vast unfolding story of everything, you get to be part of it not as a spectator, watching from outside, but as a genuine piece of the universe itself, temporarily arranged into something capable of looking back at the whole story and feeling something about it. That's enough. It doesn't need to lead anywhere else. It doesn't need to mean anything more than what it already is. 13.8 billion years, leading gently, patiently, improbably to this exact, ordinary, quiet moment. Sleep well tonight. The universe isn't going anywhere. It will still be here tomorrow, just as old, just as vast, just as quietly remarkable as it is right now. And so, gently will you. Welcome back for the final part of tonight's journey. We've traveled from the very first instant of existence through the birth of stars and galaxies to the formation of our sun, our earth, and the long, unbroken thread of life that began here billions of years ago. Tonight, we followed that thread a little further to the slow emergence of minds, and finally back to you. From simple to aware. For an extraordinarily long stretch of Earth's history, billions of years, in fact, life existed, but it was simple, single cells drifting in ancient oceans with no eyes to see, no minds to wonder, no awareness, as far as we can tell, of anything at all. Just the quiet, persistent chemistry of survival and reproduction, repeating itself generation after generation for an almost unthinkable span of time. It's worth sitting with how long this phase actually lasted. If you compress the entire history of life on Earth into a single day, complex, multicellular life with actual bodies, distinct from simple single cells, doesn't appear until quite late in the evening. And anything resembling a nervous system, anything capable of sensing its environment in a coordinated way, comes later still. Slowly, gradually, through countless small variations and countless small advantages, more complex forms of life emerged. Simple sensing abilities, then more coordinated responses, then eventually something we'd recognize as a nervous system, a way of gathering information about the world and responding to it faster and more flexibly than simple chemistry alone ever could. I think it's worth pausing here to appreciate just how strange and how gradual the emergence of anything like awareness actually was. There was no single moment when unaware became aware. It was a long, slow gradient stretching across hundreds of millions of years, with each small step barely distinguishable from the one before it, until, looking back across the whole span, the difference between a single ancient cell and a creature capable of sensing, responding, even eventually remembering, becomes almost impossible to comprehend as a single continuous process. And yet, that's exactly what it was. One continuous, unbroken thread stretching from the simplest possible beginning to something capable, eventually, of far more, the slow climb toward thought. As life continued to diversify across hundreds of millions of years, filling oceans, then land, then air, in countless different forms, nervous systems continued to grow more complex in certain lineages. More capacity for sensing the environment, more capacity for learning, for remembering, for adjusting behavior based on past experience rather than relying purely on instinct. This happened gradually and in many different branches of life to many different degrees. It's not a straight line leading inevitably toward humans the way it's sometimes mistakenly imagined. It was and remains an enormous branching tree with complexity and capability emerging independently in different ways in many different kinds of creatures, each suited to their own particular way of surviving in their own particular environment. But in one particular branch of that enormous tree, the branch that eventually led to mammals, and within mammals to primates, something kept happening generation after generation across millions of years. Brains, relative to body size, kept growing larger, more capacity for complex thought, more capacity for social behavior, for cooperation, for passing knowledge between individuals, not just through instinct, but through observation and eventually through something far more powerful, language. And somewhere in that long, gradual process again, with no single dramatic moment marking the change, a particular kind of awareness emerged. Not just sensing the world and responding to it, something more. The capacity to reflect on your own existence, to wonder not just about your immediate surroundings, but about where you came from and what waits beyond what you can see. To ask, in whatever form the earliest version of this question took, something like, what is all of this and why does it exist at all? As far as we know, and I say this carefully, because it's genuinely difficult to know with certainty, this kind of deep, reflective self-awareness fully developed is something quite rare, even among the enormous diversity of life on Earth. Many creatures show forms of intelligence, problem solving, even some degree of self-recognition. But the particular combination found in humans' language complex enough to describe abstract ideas, memory capable of constructing detailed narratives about the past and future, and the capacity for genuinely open-ended reflection on one's own existence appears to be something quite distinct, a universe that looks back at itself. Here's a thought I find myself returning to again and again in stories like this one. For nearly the entire history of the universe, 13.8 billion years, minus a tiny, almost negligible final sliver, the universe simply existed, vast and magnificent and entirely unobserved by anything capable of appreciating it. Galaxies formed and drifted. Stars were born, lived, and died, scattering the elements that would eventually form planets and eventually life. All of it happened. All of it was real. And none of it, for that almost entire span of time, was witnessed by anything capable of understanding what it was looking at. And then very recently, in the most literal sense, an almost vanishingly small sliver of cosmic time, something changed. On at least one small planet, around one ordinary star, in one ordinary galaxy, the long, slow climb from simple chemistry to complex life to reflective awareness finally produced something genuinely new in the history of the universe, a way for the universe to look back at itself and wonder what it was. Every time you look up at the night sky, you're not simply an observer separate from what you're observing. You're the universe examining itself through the very particular and very temporary arrangement of atoms that happens to be you. The light entering your eyes, having traveled for years or centuries or longer, is being received by a structure, a brain built from elements forged inside stars, shaped by billions of years of evolution, capable, somehow, against every reasonable expectation, of understanding at least a little of what it's looking at. That's an extraordinary thing. Not extraordinary in the sense of being supernatural or breaking any rules of how the universe works. Quite the opposite. It's extraordinary precisely because it emerged entirely from those rules, given enough time, enough patience, enough of the universe's vast, quiet persistence. the moment you're in. So here we are, finally, at the end of this very long story, 13.8 billion years, compressed into a single night's listening, arriving at last at this exact moment. You lying here in whatever room you're in whatever country, at whatever hour, are the most recent chapter in a story that began before time itself, in any meaningful sense, existed. Every atom in your body has its own ancient history, forged in stars that lived and died long before our sun ignited. The water nearby, if there's a glass of it by your bed, has likely existed in one form or another, cycling through oceans and clouds and rivers for longer than humans have existed at all. The thoughts moving through your mind right now are the product of billions of years of gradual, patient evolution, building step by step toward exactly this capacity to wonder, to reflect, to feel something about your own brief, remarkable existence. None of this needed to happen. There's no law of the universe that guaranteed life would emerge, or that intelligence would follow, or that, after 13.8 billion years, anything would exist capable of telling the story or capable of listening to it. And yet, here we both are the story being told, and you receiving it on this particular night, in this particular moment, which will never happen again in exactly this way. I think that's worth sitting with gently as you drift towards sleep tonight. Not as a reason to stay awake, turning it over and over in your mind, but as a quiet, settled kind of comfort. You are not separate from this enormous story. You are its most recent moment, its current edge, the place where 13.8 billion years of cosmic history happens to be standing right now, looking back at all of it for just a little while before drifting off into something quieter still. A closing thought. As we close tonight, I don't want to leave you with more facts or more numbers. I want to leave you with something simpler. Whatever happens tomorrow, whatever ordinary or difficult or wonderful things tomorrow holds, it will be one more day in a story that already includes 13.8 billion years of stars, galaxies, oceans, and quiet, patient becoming. Your place in that story doesn't need to be grand or remembered or extraordinary in any visible way to matter. It already matters, simply by existing the same way every star that ever formed mattered, the same way every quiet, unremarkable moment of Earth's long history mattered, simply by being part of the unbroken chain that led eventually here. So tonight, let yourself rest inside that thought. You are old stardust, briefly arranged into something capable of wonder, lying quietly on a small blue planet, circling an ordinary star in a vast and patient universe that has been unfolding gently for longer than anything you could ever fully imagine. That's enough. It always has been. Sleep well tonight. Before we begin tonight, I want to ask you something the way I always do. Tell me where you're listening from, what country, what city, if you'd like to share, and tell me what time it is for you right now, because somewhere as you hear these words, it is very late and the house around you has gone quiet and the only sound is your own breathing, and perhaps this voice somewhere else. It is just past midnight and the day that just ended already feels like a distant thing, and somewhere perhaps it is almost morning, the sky outside just beginning to soften at its edges, not yet light, but no longer quite dark either. I like thinking about all of you, scattered across so many time zones, so many rooms, so many different kinds of nights, each of you in your own way, arriving at the same place, ready finally to set the day down, ready to let your mind drift somewhere quieter. Tonight, we're going to finish something we started. And I want to take a moment before we begin to acknowledge what that means. We've been on a long journey together. We began at the very beginning, before time itself had any meaning, before space existed to contain anything, before the very concepts of before and after had anything to apply to. We walked through the first light, through the long dark ages of an early universe with no stars, through the birth of the first suns, the slow gathering of galaxies, the quiet formation of our own unremarkable but precious solar system. We arrived at Earth violent and molten at first, then gradually, patiently, over billions of years, becoming something stable enough, tempered enough, liquid enough for life to begin. And we followed that thread of life unbroken, never interrupted, stretching across nearly 4 billion years from the simplest possible beginnings through the long, slow climb toward complexity, toward awareness, toward the particular kind of mind that can lie still in the dark and wonder about where it came from. We ended last time with you, right there in that room on that night, as the most recent chapter in a story 13.8 billion years in the making. Tonight, we go further. Tonight, we're going to do something slightly different from what we've done before. We've already told the large-scale story, the cosmic story, the geological story, the biological story. Tonight, we're going to zoom in. We're going to come closer to home. We're going to look not just at the universe that produced us, but at the particular and remarkable story of what happened here on this small planet. Once life had established itself and begun its long, patient experiment in complexity, we're going to look at time differently, not the vast, almost ungraspable timescales of cosmology, but the somewhat more manageable, though still enormous, timescales of life on Earth. We're going to look at how life changed this planet and how this planet changed life in a conversation that has been ongoing for nearly 4 billion years. And then, eventually, we're going to come all the way into the human story, the story of minds like yours, and what it means to be the kind of creature that tells stories about where it came from at night, in the dark, before drifting off to sleep. So get comfortable. Let your breathing slow. Settle your weight into wherever you're lying or sitting right now, and feel the solidity of the surface beneath you, solid ground that has been here in one form or another for billions of years and will continue to be here in one form or another long after either of us is around to appreciate it. Let's begin. Section 2. A planet that learned to breathe. We left Earth at a particular moment, a moment roughly 3 to 4 billion years ago, when the first living things had just appeared. The planet at that point was, by our current standards, an almost alien place. Imagine standing on the surface of early Earth, if such a thing were possible. The sky above you would look nothing like the sky, you know? It would be a strange, hazy color, not the familiar blue of today, not because the sun was any different, but because the atmosphere itself was radically different. Very little free oxygen, mostly nitrogen, carbon dioxide, methane, water vapor, a sky that no human lungs could have breathed. A world that, by the standards of the creatures who would eventually come to call it home, was entirely inhospitable. The oceans existed vast, covering much of the surface, as they do now, but their chemistry was different. Their color, some scientists believe, might have been more greenish than blue, tinged by dissolved iron and other minerals in concentrations that would be toxic to most of the life we know today. And yet, in those oceans, something was alive. The first living things were extraordinarily simple by any standard we would apply today, simple enough that the question of what exactly counts as alive versus not quite alive yet becomes genuinely difficult to answer when we look at their earliest ancestors. But they were alive in the sense that matters most. They took in materials from their environment, they processed those materials into forms useful to themselves, and they reproduced, passing along the information needed to make more of themselves to the next generation. This fundamentally is what life does. This is what life has always done, from those first barely their beginnings to the richly complex living world we know today. The details change, the structures become more elaborate, the strategy become more varied and ingenious, and sometimes almost impossibly sophisticated. But the core of it, taking in, processing, reproducing, passing forward, has never stopped, not once in nearly 4 billion years. Think about that unbroken continuity for a moment. Every single living thing alive today, every tree, every insect, every fish, every fungus, every bacterium, every blade of grass, every cloud of microscopic organisms floating in a drop of ocean water, every single one of them can trace an unbroken chain of ancestry back to those first living things in the early ocean. Not a chain that almost broke and was reconnected, not a chain that went extinct somewhere and had to start fresh. A single, continuous, unbroken lineage, stretching from then to now, from those first barely living chemical systems to you lying here tonight, with your extraordinarily complex brain processing these words and building them into meaning and feeling. You are, in the most literal and direct possible sense, part of that unbroken chain. Now, for a very long time after life appeared, for a period so long it strains the imagination to hold, life stayed simple. Simple, but not static. Simple, but already beginning the process that would eventually transform the entire planet. The early living things we know most about from this period, called in the scientific literature prokaryotes, meaning cells without a distinct central nucleus, were already remarkably sophisticated at the level of chemistry, even if they were tiny and structurally very simple. And among these early life forms, one particular group would eventually do something of genuinely world historical importance. Something that would change the planet so fundamentally that the change is sometimes called the greatest environmental catastrophe in Earth's history, and yet, at the same time, the change that made almost everything that came after it possible. These were the cyanobacteria, and what they did was learn to photosynthesize. Photosynthesis, the process of capturing energy from sunlight and using it to build organic molecules from carbon dioxide and water, is something we take for granted now, because plants do it constantly all around us and have done so for hundreds of millions of years. But when the cyanobacteria first developed this capability, it was genuinely new, a new way of harvesting energy that no life form had used before. And photosynthesis, as it turns out, produces a byproduct, oxygen. For a very long time after cyanobacteria appeared, hundreds of millions of years, the oxygen they produced was quickly absorbed by the environment. There was so much iron dissolved in the early oceans that the oxygen combined with it almost immediately, forming iron oxide, the mineral we know more commonly as rust, which sank to the ocean floor and was incorporated into the rock record. You can see the evidence of this process today in rock formations called banded iron formations, layers of iron-rich stone laid down over millions of years, a geological diary of the cyanobacteria's long, slow transformation of the world's chemistry. But eventually, the oceans ran out of iron fast enough to absorb all the oxygen being produced. The cyanobacteria kept producing, and the oxygen, with nowhere else to go, began to build up in the atmosphere. This was, for many of the living things that existed at the time, genuinely catastrophic. Oxygen is reactive, it attacks organic molecules, disrupts chemical processes, is essentially toxic to organisms that evolved in an oxygen-free environment. Many of the life forms that had flourished in the early oxygen-free world couldn't survive in an atmosphere that was becoming increasingly oxygen-rich. Some retreated to environments where oxygen couldn't easily reach, deep sediments, isolated corners of the ocean. Their descendants still live in such places today, in the mud of lake bottoms, in deep underground rocks, in the guts of animals like us who provide them with an oxygen-free habitat. But for other life forms, the ones that could tolerate oxygen, or better yet, could use it, this transformation of the atmosphere was not a catastrophe but an opportunity. A vast, world-changing opportunity, because oxygen, that same reactive molecule that was so dangerous, could also be harnessed. Life forms that developed the ability to use oxygen in their metabolic processes to burn organic molecules with oxygen. The way a fire burns fuel found themselves with access to far more energy than anything that had come before. Oxygen-based metabolism is, by certain measures, roughly 16 times more efficient than the alternatives. With more energy available, more complex structures became possible. More elaborate behaviors became possible. More of everything became possible. The transformation of Earth's atmosphere by the cyanobacteria, the event scientists sometimes call the Great Oxygenation Event, which occurred roughly 2.4 billion years ago, was, in this sense, both a mass extinction and a liberation, a catastrophe for some, and the foundation for an entirely new chapter of life on Earth. It's a strange kind of story, one in which the greatest disaster and the greatest opportunity are the same event, depending on which side of it you were on, which is perhaps a pattern worth noticing as stories go. Section 3. The invention of the cell. For the first half of life's existence on Earth, roughly 2 billion years out of a nearly 4 billion year history, all life was made of a particular kind of simple cell, small, structurally uncomplicated, without a distinct nucleus, without the elaborate internal compartments and structures that the cells of plants and animals and fungi have. And then something happened, something so unusual, so unlikely in the normal course of how evolution works, that scientists spent a long time arguing about whether it had really happened the way the evidence suggested. It had, at some point, one cell swallowed another, and instead of being digested, instead of simply being broken down and used as food the way one organism normally uses another, something different happened. The swallowed cell survived, and it found inside its new host an environment that suited it. And the host cell found in its new internal resident something useful, something it couldn't produce on its own. This relationship, where one organism lives inside another to the mutual benefit of both, is called endosymbiosis. And the endosymbiotic event that happened somewhere in the history of early life on Earth gave rise to a new kind of cell, far more complex than anything that had existed before, with specialized internal compartments capable of doing things no previous cell could do. The descendants of the cells that were swallowed are still with us, living inside the cells of every plant, every animal, every fungus, every complex living thing on Earth. We call them mitochondria, the structures inside our own cells that convert oxygen and fuel into the energy that powers everything we do. They have their own DNA, separate from the DNA in our cell's nucleus, the remnant of their independent ancestry billions of years ago, before they became a permanent part of us. Every breath you take right now is serving them as much as it serves you. In a very real sense, you are not a single organism. You are a collaboration, a community of cells and their ancient microbial partners working together the way they have worked together for well over a billion years. The emergence of the complex cell, what scientists call the eukaryotic cell, to distinguish it from the simpler prokaryotic cells that came before, was one of the key transitions in the history of life. Without it, the elaborate complexity of multicellular life would never have become possible. No animals, no plants, no fungi, no minds capable of lying awake at night wondering about the nature of the universe. It happened once. As far as we know, the transition from simple to complex cells happened exactly once in the entire history of life on Earth, and every complex living thing alive today is descended from that single improbable event. Section 4. Coming together, the story of multicellular life. For a long time after the complex cell appeared, it remained, like its simpler ancestors, a solitary thing. Single cells, living alone, the way life had always lived. But slowly, gradually, over hundreds of millions of years, something began to change. Cells started staying together after dividing. Rather than separating and going their own ways, they remained attached, a cluster of 2, then 4, then more. And as they remained together, something remarkable began to happen. The cells began to specialize. Rather than each cell doing everything a cell needed to do on its own, different cells in the cluster began doing different things. Some becoming better at sensing the environment, some becoming better at moving, some becoming better at acquiring nutrients. The first multicellular organisms were extraordinarily simple, little more than clumps of cells, barely distinguishable from a colony of single cells that happened to be stuck together. But over time, the specialization increased. The division of labor deepened, and as more and more roles differentiated, as more and more specialized structures developed, the range of what was possible expanded enormously. This transition from single cells to cooperating, specialized communities of cells happened multiple times independently in different branches of life. It happened in the ancestors of animals. It happened in the ancestors of plants. It happened in the ancestors of fungi. Each time, separately, with different solutions to the same basic challenges. But the results, in terms of the possibilities it opened up, were transformative. Multicellular organisms could be large in a way no single cell could be. They could be differentiated with different parts of themselves doing different things. They could be long-lived, far beyond the lifespan of any individual cell. And they could develop the most complex structures. Life had yet produced structures that would eventually give rise to something the universe had never seen before, a way of experiencing the world from the inside. Section 5, the Cambrian moment. There's a period in the history of life on Earth that has fascinated scientists ever since the 19th century, when geologists first began systematically mapping the rock record and noticed something extraordinary. In rocks from a certain period, roughly 538 million years ago, a geological boundary known as the start of the Cambrian period, something happened in the fossil record that looks almost like an explosion. Below this boundary, the fossils found are relatively few and relatively simple, traces of soft-bodied organisms, impressions in ancient mud, evidence of life, certainly, but life of a mostly modest, uncomplicated kind. Above this boundary, almost immediately above it, in geological terms, the picture changes dramatically. Suddenly, the fossil record is full of animals with hard shells, hard skeletons, complex body plans, eyes, legs, claws, mouths. The full range of body plan types, arthropods, mollusks, echinoderms, early ancestors of the vertebrates, appears within what seems on geological timescales, like a geological heartbeat. Scientists call this the Cambrian explosion, and it has been the subject of enormous study and, at times, debate. What triggered it? Why did so many complex animal body plans appear in such a relatively short period of geological time? Was it really as sudden as it looks? The answer, like most answers in deep history, is nuanced. The explosion was not instantaneous. It played out over several million years, which is very fast in geological terms, but is still an enormous span of time in human terms. And the life that appeared during it had deep roots in the Precambrian world that preceded it. It didn't emerge from nothing. The genetic tools, the developmental systems, many of the building blocks of complex animal bodies were already present, already being refined in the hundreds of millions of years before the Cambrian. But something did change. Something, possibly the rising levels of oxygen in the oceans and atmosphere, possibly changes in the chemistry of the seas, possibly the development of predation and the evolutionary arms race it triggered, possibly some combination of all of these and more opened the door, and life, with the patient inventiveness that characterizes all of its history, walked through it. For the first time, animals with complex bodies were exploring the world. Animals with eyes, seeing it for the first time. Animals with nervous systems, experiencing it from the inside for the first time. Animals with the capacity, however rudimentary and simple by later standards, to move, to sense, to respond, to pursue, to flee. The world of subjective experience of what it is like to be somewhere, to see something, to feel something had its beginning somewhere in this explosion of complexity, not fully formed, not sophisticated by any later measure, but present in some minimal and perhaps unrecognizable form for the first time. The universe was beginning, in the most tentative and initial of ways, to look at itself. Section 6. Life leaves the water. For the first roughly 90% of life's history on Earth, everything lived in water. The oceans were full and growing fuller, more diverse, more complex, more elaborately interwoven in the relationships between predators and prey, between organisms and their environments. But the land was mostly bare, rocky, scoured by ultraviolet radiation that, without the ozone layer that would eventually form from the accumulating oxygen in the atmosphere, made the surface a harsh and largely inhospitable place. Slowly, over hundreds of millions of years, that began to change. The first organisms to make the transition to land were simple ones, the ancestors of mosses and liverworts, tiny plants that could survive on wet surfaces, slowly, incrementally developing the structures needed to live in the new environment. They had to solve problems that life in water had never needed to solve: how to keep from drying out, how to transport water and nutrients internally rather than simply absorbing them from the surrounding medium, how to reproduce without the watery environment to carry reproductive cells. They solved them slowly, generation by generation, with the patient, incremental genius of evolution. They solved them. And as they did, they began transforming the land around them, breaking down rock into soil, adding organic material to the growing layer of earth, changing the very substrate on which they lived, making it more hospitable for the generations that followed. After the plants came the animals. Arthropods, first the ancestors of today's insects, spiders, millipedes, already well equipped with external skeletons that could resist drying out, already capable of breathing air in ways that aquatic ancestors hadn't needed to develop. And then, much later and much more gradually, the ancestors of land vertebrates, creatures that had begun their lives in the water but were developing over millions of generations, the capacity to make longer and longer excursions onto land until eventually land was home. The transition from water to land is one of the great themes of life's history, not because it happened once and ended, but because it happened repeatedly in different lineages at different times, each time solving the same fundamental set of problems in slightly different ways. And it's still happening. In a sense, the history of life on land is the history of increasingly sophisticated solutions to the challenges that terrestrial existence poses, solutions that have given rise to the extraordinary diversity of land life we know today. I want to pause here briefly, not to add more facts, but to invite you to feel something. We're 450 million years ago, roughly. Life on land is still new. The landscape looks nothing like anything you'd recognize. No forests yet in anything like their current form. No grasslands, no flowering plants. Strange, fern-like growths, low to the ground. Insects beginning to explore the air for the first time. No birds, no mammals, no creatures with anything remotely resembling human intelligence. And yet this is the world that contains the beginning of you. Not you specifically, not your species, not even your phylum yet, but the unbroken thread that leads to you is there somewhere in those early terrestrial creatures swimming in those Devonian seas, making those first uncertain steps onto muddy carboniferous shores. Every time I think about this, about the depth of the lineage that led to any of us, I find something like vertigo and something like comfort in equal measure. The vertigo of scale. How many generations, how many lives, how many individual creatures have lived and died and been forgotten on the long road to now? The comfort of continuity, that through all of it, through all of the changes and upheavals and transformations, the thread was never broken. It is not broken now. You are here because it wasn't Section 7, the age of great creatures. For a very long stretch of time, from roughly 350 million years ago to 66 million years ago, the dominant large animals on land were reptiles. Specifically, for much of this period, a particular group of reptiles that arose and diversified into an extraordinary range of forms, filling ecological roles that had never been filled by large land animals before. We call them dinosaurs. I want to be careful here because the word dinosaur tends to summon a particular set of images, the ones from films and books, fierce and enormous and dramatic. And while some dinosaurs were indeed fierce, enormous, and dramatic, the group as a whole was far more diverse and varied than these popular images suggest. There were dinosaurs the size of modern chickens and dinosaurs the size of buildings. There were dinosaurs that ate plants, that ate insects, that ate fish, that ate other dinosaurs. There were dinosaurs that traveled in vast herds across open landscapes, and dinosaurs that were solitary hunters, and dinosaurs that, for reasons we're still working to fully understand, developed complex social behaviors. And there were, among the dinosaurs, creatures that did something no large land animal had managed before. They took to the air. The birds, yes, birds, which are, in the most technically accurate sense, living dinosaurs, a lineage that survived the great extinction that ended the age of their larger relatives, represent one of the most remarkable evolutionary transitions in the history of life on land, from small, feathered theropod dinosaurs over tens of millions of years. Flight was gradually refined, feathers were gradually reshaped, bodies were gradually lightened and restructured until what had been a running, leaping creature became something capable of sustained, powered flight. Birds exist today remarkably, improbably, beautifully, because one group of dinosaurs survived what their relatives did not. And they are, by many measures, the most species-rich group of large vertebrates alive today, found on every continent, in every kind of environment, from the deepest jungles to the edges of the polar ice. If you've listened to birdsong today, you've heard a dinosaur. But while the dinosaurs dominated the land during the Mesozoic era, another group was quietly, patiently developing in the shadows. Mammals, or more precisely, the mammal-like animals from which true mammals would eventually evolve, had actually appeared at roughly the same time as the first dinosaurs in the late Triassic period. For nearly the entire subsequent history of the dinosaurs' dominance, however, mammals remained small. Most of them were tiny, shrew-sized or smaller, living in burrows, foraging at night to avoid the large reptiles that dominated the day. Small, nocturnal, warm-blooded, and in being warm-blooded, developing something significant, the capacity to maintain a constant internal body temperature regardless of the temperature of the environment. This required significant energy. A warm-blooded animal needs to eat far more than a cold-blooded one of the same size, but it also gave mammals something valuable: the ability to remain active in conditions where cold-blooded animals became sluggish or inactive. The cold of night, the chill of early morning, the cold seasons, these were less of a barrier for warm-blooded mammals than for the cold-blooded reptiles alongside which they lived. During the long age of the dinosaurs, mammalian brains were also quietly growing in complexity. The demands of nocturnal life, navigating in low light, relying more on hearing and smell than on vision, may have driven developments in certain sensory and processing regions of the brain. The demands of caring for helpless young, something mammals do, in which their mammal-like ancestors increasingly did, required new kinds of behavior, new kinds of social complexity, new kinds of brain function. Small, hidden, mostly overlooked in the grand drama of the Mesozoic world, but developing quietly in the background, the foundations of something that would matter enormously once the world changed. Section 8. The world that ended and the world that began 66 million years ago, an eye blink ago, in the long story of life on Earth, but an almost unimaginable span of time. From any human perspective, something happened. A rock, roughly 12 kilometers across, moving at extraordinary speed, arrived without warning from space and struck what is now the Yucatan Peninsula of Mexico. The immediate effects were catastrophic beyond any scale of disaster our species has ever experienced. The impact released energy equivalent to billions of nuclear weapons. The rock itself vaporized in an instant. The material thrown up from the impact side, pulverized rock, superheated gas, debris spread across the atmosphere in hours. Some of it went into orbit and fell back to Earth across the entire planet, heating the atmosphere to temperatures that set forests on fire on multiple continents simultaneously within hours of the impact. And then the darkness came. Debris and smoke and sulfate aerosols from the impact filled the atmosphere and blocked the sun. For months, possibly for years, the sky was dark. Cold settled across the planet. Photosynthesis largely stopped. The food chains that depended on plants began to collapse from the bottom up. The food chains that depended on those food chains collapsed after them. The non-avian dinosaurs, every species, every lineage, every creature from the largest to the smallest, across every continent, were gone within what, geologically speaking, is essentially an instant. Roughly 3/4 of all species on Earth disappeared in this event and its aftermath. But not all. The birds survived perhaps because of their small size. their ability to eat seeds, which can survive underground, dormant, through cold and darkness, their already well-developed mobility. Some reptiles survived. Some mammals survived, particularly, it seems, the small, burrowing, seed-eating ones who could take shelter underground, who were already adapted to living in difficult conditions, who perhaps had just enough resilience to endure the catastrophe that ended so much else. And in the world that existed after the impact, a world emptied of its dominant species, full of ecological niches that had been vacated almost overnight, the survivors found something they had never had before: room to grow, room to diversify, room to expand into the ecological roles that had previously been filled by the creatures that were gone. The mammals, specifically, diversified with a speed and variety that is genuinely astonishing to look at in the fossil record. Within a few million years of the extinction, which sounds like a long time but is geologically rapid, mammals had spread into an enormous range of new forms and lifestyles, where before they had mostly been small and nocturnal and hidden, they now began producing large herbivores, large predators, creatures adapted to life in trees, creatures adapted to life in water, creatures adapted to open plains and dense forests and every kind of environment the recovering earth offered. Among these diversifying mammals, one particular group began to develop in its members something that would eventually matter more than almost anything else that had ever developed in the history of life. They were the primates, and what they were developing slowly was the capacity for increasingly complex minds. Section 9. The primates and the long climb toward mind. The earliest primates appeared very shortly after the mass extinction that ended the age of dinosaurs, small tree-dwelling creatures with eyes facing forward, allowing better depth perception, useful for judging distances in trees, with grasping hands capable of holding branches, with somewhat larger brains relative to body size than most other mammals of similar size. For tens of millions of years, primates diversified across a warming world, a world in which tropical and subtropical forests stretched much further across the planet than they do today, providing an enormous range of arboreal habitats for tree-living animals. They spread across Africa, Europe, Asia, the Americas. Over time, some lineages developed larger bodies, larger brains, more complex social structures. The apes, the group of primates that includes gibbons, orangutans, gorillas, chimpanzees, bonobos, and humans, appeared in Africa and Asia roughly 20 to 30 million years ago, gradually differentiating from the monkeys and other primates from whom they descended. In the apes, social complexity became particularly pronounced. Living in groups, navigating the complex social relationships within those groups. Who is dominant? Who is allied with whom? Who can be trusted? Who might be a threat placed new demands on social intelligence. Keeping track of many individuals and their relationships, predicting behavior, understanding that others have minds of their own with their own knowledge and intentions. These are cognitively demanding tasks, and the demands may have driven the continued enlargement and elaboration of the primate brain. Among the great apes of Africa, one particular lineage began between roughly 6 and 7 million years ago to diverge from the ancestors of the chimpanzees and bonobos, our closest living relatives. This diverging lineage would, over the next several million years, produce a series of species with a particular unusual set of characteristics. They walked upright. Bipedalism, walking on two legs, is among mammals highly unusual. Most mammals that walk at all use 4 limbs. The transition to upright walking in the human lineage required significant restructuring of the skeleton, the hips, the spine, the foot, the way weight was distributed and balanced. It came with costs. The upright posture that freed the hands from walking also made childbirth more difficult because the same pelvis that had to accommodate the upright body also had to allow the passage of increasingly large-brained infants. But it also freed the hands entirely for uses other than locomotion. And hands free to manipulate objects with great precision became, in the human lineage, tools of extraordinary versatility. Section 10. The making of the human mind. The story of human evolution is, in many ways, the story of a brain that kept growing. Over the several million years that separate us from our earliest upright walking ancestors, the brain size of creatures in our lineage roughly tripled. From roughly 400 cubic centimeters in the earliest hominins, creatures that were upright walking but in many ways still more ape-like than human in their cognition, to the roughly 1,400 cubic centimeters of the modern human brain. This is an extraordinary increase by evolutionary standards over a relatively short period of geological time. And it wasn't just size that changed the structure of the brain, changed too, with particular expansion and elaboration in regions associated with planning, social cognition, language, and abstract thought. What drove this expansion? Scientists have proposed many factors, and the honest answer is probably that several of them work together, each amplifying the others. Tool use is one candidate. Making and using tools, especially the increasingly sophisticated stone tools that appear in the archaeological record of our ancestors, requires planning, fine motor control, spatial reasoning, and the ability to understand how objects can be shaped and used in ways that are not immediately obvious from their natural form. Creatures better at this had advantages, and the cognitive capacities that enabled it were favored. Social life is another. The complex social environments of early human groups, keeping track of many relationships, navigating alliances and conflicts, understanding what others know and intend, predicting behavior place high demands on social cognition, and groups with more sophisticated social brains may have navigated these environments more successfully. But perhaps the most important factor, and the one that distinguishes human cognitive evolution most sharply from anything that came before, is language. Language is genuinely difficult to overstate in its importance. Other animals communicate. Many animals communicate remarkably well, conveying information about the location of food, the presence of predators, their own emotional states, their social status, their intentions. Some animals, other great apes, certain cetaceans, some birds show capacities for communication that approach, in certain limited ways, the early stages of language. But human language is something categorically different in several ways that matter enormously. First, it is compositional. It allows an essentially unlimited number of different messages to be constructed from a finite set of elements, words, grammatical structures, in a way that allows meanings that have never been expressed before to be expressed clearly and understood. Second, and perhaps more importantly for the story of the human mind, it allows the externalization of thought. With language, ideas that exist in one mind can be transferred imperfectly, always, but often adequately, to another mind. Knowledge that one individual has acquired can be shared with others who didn't acquire it themselves. And those others can build on it, add to it, share it further. This capacity for cumulative cultural transmission, for building on the knowledge of previous generations, rather than each individual having to acquire everything from scratch, is what allows human knowledge to accumulate across time in a way that no other species has achieved. The discoveries of one generation become the foundation of the next. The tools developed over many generations become more sophisticated than any individual could have invented alone. The understanding of the world that a person alive today has access to represents not just their own experience, but the accumulated experience, insight, and discovery of hundreds of generations before them. That is what language made possible. And what it made possible, eventually, was everything that followed. Section 11. The first fires, the first stories. There's a moment in the long story of human prehistory that I find myself returning to again and again when I try to imagine what it must have been like to be an early human. The fire. The archaeological evidence suggests that members of our lineage were using fire regularly, perhaps controlling it, perhaps making it deliberately at least several 100,000 years ago, and possibly much earlier. Fire was, for early humans, transformative in ways that are difficult to fully appreciate from where we stand now in a world so thoroughly reshaped by our species' technological capacities. Fire meant warmth in cold environments. It meant protection from predators in the dark. It meant light in a world that, before fire, was completely dark after sunset, a darkness so total that it is almost impossible to imagine from within the perpetual, pervasive, artificial illumination of the modern world. But perhaps most significantly for the development of the human mind, fire meant time. Time in the evenings, gathered around the light and warmth, with the work of the day done time for something that had no direct, immediate survival value, but that would prove to be one of the most important inventions in human history. Time for stories. We don't know and can never know for certain exactly when humans began telling stories. The capacity for language, which is the prerequisite for storytelling, evolved gradually and left traces in the fossil record only indirectly in the structure of the skull, the position of the hyoid bone, the inferred size and shape of the brain areas associated with language. But we can make reasonable inferences. The cognitive capacities associated with narrative, the ability to arrange events in time, to understand causation, to create and inhabit imagined scenarios, to understand that others have their own perspectives and experiences, were likely developing alongside language itself, and for many of the same reasons. Stories, once possible, would have been extraordinarily valuable. A story about where the best hunting grounds are and how to get there. A story about what happened to someone who did a particular dangerous thing. A story about the group's history, about who was related to whom, about what obligations and relationships existed. A story about the world, about why things were the way they were, about what forces shaped the seasons and the weather and the movements of animals and the growth of plants. Stories were, for early humans, technology, a way of storing and transmitting information that had no other way of being preserved, a way of making the experiences of individuals available to the group, a way of making the experiences of the past available to the present. Section 12. The Great Journey. For most of our species' existence, modern humans, Homo sapiens, appear in the fossil record in Africa at least 300,000 years ago, though the precise dates and the story of our species' origins are still being refined by ongoing research. We lived as our ancestors had for millions of years before, in small groups, moving through the landscape, hunting and gathering the food that the land provided. But at some point, the most recent evidence suggests beginning roughly 100,000 years ago, with a major expansion perhaps 60 to 70,000 years ago, though this too is a subject of active research. Something changed. Members of our species began moving. not just locally, not just within the familiar landscapes of the African savannas and forests where we had evolved, but far beyond them, out of Africa, across the land bridges and islands of the ancient world, into the Arabian Peninsula, into South and Southeast Asia, eventually into East Asia and Australia. Later, into Europe, and then in the most recent chapter of this global expansion across the land bridge that connected what is now Siberia to what is now Alaska, and then gradually over thousands of years down through the entire length of the Americas, from the Arctic to the tip of South America. By roughly 15,000 years ago, and in some places much earlier, humans had reached and established themselves on every continent except Antarctica. We had adapted to Arctic tundra and tropical rainforest, to high-altitude plateaus and island archipelagos, to deserts and grasslands and coastlines. We had become far and away the most widespread large land animal on the planet, not because we were the physically strongest, not because we were the fastest, not because we had the most formidable natural weapons, but because we were adaptable in a way that no other species was. We could survive almost anywhere because we could invent the tools and techniques needed to survive there. We could pass those inventions on through language, through teaching, through the accumulation of knowledge across generations. And we could cooperate in groups of a complexity and scale that no other species approached, cooperate with strangers, cooperate across distances, cooperate in pursuit of goals too large for any individual or small group to achieve alone. This capacity for flexible, large-scale cooperation, enabled by language and the shared stories and beliefs that language made possible, is the most powerful adaptive tool our species has ever developed. Section 13. The invention of agriculture and the transformation of the world. For roughly 95% of our species' existence, we lived as hunter-gatherers, small, mobile groups following the seasonal availability of food, living lightly on the landscape, leaving little permanent trace of our presence. And then, beginning roughly 10 to 12,000 years ago, in several places around the world, independently, something changed. People began farming. The transition to agriculture was not a single invention, not a moment of sudden insight. It was, like everything in human history that looks sudden from a distance, a long and gradual process, centuries and millennia of increasingly close relationships with particular plants and animals, of incipient management and tending, of gradual selection of individuals with desirable traits, of slowly shifting from mostly harvesting what grew wild to increasingly ensuring that the desired species would grow in the places where you wanted them. But the consequences, once agriculture became established, were transformative in ways that reach all the way to the present moment. Agriculture allowed and, in a sense, required a kind of permanence that hunting and gathering didn't. If you've planted crops, you need to stay to harvest them. If you've invested effort in managing a field or a flock, you need to remain nearby to protect and tend it. Agriculture anchored people to places in a way that their ancestors had never been anchored. From that anchorage, everything else followed. Permanent settlements, villages, then towns, then cities. The storage of surplus food, more than could be immediately consumed, which required storage structures and record keeping, and eventually writing. The specialization of labor, because when food production is efficient enough that not everyone needs to be involved in it full time, some people become potters, and some become smiths, and some become traders, and some become administrators, and some become priests, and eventually some become scribes, and philosophers, and artists, and engineers. Writing appeared in several places independently roughly 5 to 6,000 years ago. And with writing, something fundamental changed in the capacity of human knowledge to accumulate. Before writing, everything that was known had to be carried in living memories, transmitted through oral tradition, vulnerable to loss whenever the people who carried it died without passing it on. With writing, knowledge could be recorded outside of any individual mind, stored, preserved, retrieved, built upon across generations in a new and far more robust way. The books, the records, the letters, the accounts that early writing systems produced were not mostly the profound philosophical or literary works that later came to be associated with written culture. They were grocery lists, tax records, inventories of goods, the prosaic business of managing increasingly complex societies. But even in their prosaic form, they represented something extraordinary, the first time that human knowledge had found a home outside of human minds. Section 14, Civilizations and the Long Conversation. Out of the agricultural settlements that spread across the temperate zones of the world, civilizations grew. River valleys were particularly fertile ground for them. The Nile, the Tigris and Euphrates, the Indus, the Yellow River, rich soils, dependable water, the agricultural surplus to support complex societies, and the rivers themselves as highways for trade and communication. Each civilization that emerged was, in many ways, a unique experiment, a particular solution to the challenges of organizing large numbers of people, producing and distributing food and goods, managing conflict within and between groups, understanding and explaining the world, marking the passage of time, creating meaning and beauty and shared identity, and yet, across the vast diversity of human civilizations, across cultures separated by thousands of kilometers and thousands of years, cultures that had no direct contact with one another, that developed in complete independence, certain patterns appear again and again, certain questions that every civilization asked, certain answers they reached, sometimes separately, in forms that echo across the distances. Questions about where the world came from and why, about what forces shape the seasons in the heavens, about what happens after death, about how people should treat one another, about what makes a life well lived and what makes a society just. Every civilization, as far as we know, grappled with these questions. Every civilization developed stories, myths, cosmologies, religious traditions, philosophical systems as frameworks for understanding them. And across the enormous diversity of these stories, there are patterns, not because the stories were copied from one another, but because they emerged from the same source, the human mind with its universal structure, encountering the same universal features of human experience. I find this deeply moving when I think about it. The fact that humans separated by vast distances and vast stretches of time, who had never heard of each other, who spoke completely different languages, who lived in completely different environments, asked the same questions, reached for the same kinds of answers, told stories with the same deep structures, suggests something important about what we are. We are a species that cannot help but ask why. A species that looks at the world and finds itself unable, constitutionally unable, to simply accept it without wondering about it. A species that, given any quiet moment, any night around a fire, any accumulated surplus of time and comfort, will inevitably turn to the questions that have no simple answers. Where did this come from? What does it mean? How should we live? These questions are as old as our species. They will last as long as our species lasts. And in asking them, in being the kind of creature that asks them, you are doing something that every human who has ever lived has done in some form, in some language, under some sky. Section 15. The Great Accumulation. Something changed roughly 500 years ago in the way that human knowledge grew. It changed because of a confluence of things, the printing press, which made written knowledge far cheaper and more widely available than it had ever been. The networks of trade and contact that had woven the major civilizations of the old world into an increasingly dense web of communication. The rediscovery in parts of the world that had lost them of classical texts and traditions. And perhaps most importantly, a shift in the cultural attitude toward knowledge itself. The shift was this: rather than accepting the knowledge that had been inherited from previous generations as essentially complete as a treasury to be preserved and transmitted, but not fundamentally questioned or added to a growing number of thinkers, began approaching the world as a place where new knowledge could be found. Not just remembered, not just interpreted, found, discovered, tested against reality and revised when reality disagreed. This is what we now call science, and I want to be precise about what makes it distinctive, because it's often misunderstood. Science is not simply the collection of facts about the world. Humans have been collecting facts about the world for as long as humans have existed. What science adds and what makes it such a powerful and transformative way of knowing is a particular commitment to testing ideas against reality and revising them or discarding them when the test fails. This sounds simple. It is in principle simple, and yet it runs against some of the deepest tendencies of human minds, the tendency to believe what we want to be true, to seek evidence that confirms what we already think, to resist changing our minds, especially about things that matter to us. The genius of the scientific method is not that it overcomes these tendencies in individual people. It doesn't, and it was never designed. Its genius is that it builds a social process, a community of people testing each other's ideas, demanding evidence, repeating experiments, looking for errors that corrects for these tendencies at the level of the community, even when individuals remain subject to them. The result over the past several hundred years has been an accumulation of knowledge about the physical world at a pace and to a depth that is genuinely without precedent in the entire history of our species. And the practical applications of that knowledge, technologies that have reshaped the material conditions of human life in ways that would be, to any human from even 2 centuries ago, simply incomprehensible, have followed. Section 16. The extraordinary moment we live in. I want to take a moment here as we approach the present to say something that I think is genuinely worth saying. The moment in history that you are living in is, by almost any measure we can apply, extraordinarily unusual. Not in a comfortable, familiar, everything is normal way. Unusual in a way that is genuinely dizzying if you stop to look at it clearly. We are living at a point in the story of our species and in the story of life on Earth when the pace of change is faster than it has ever been. The amount of knowledge our species collectively holds is greater than it has ever been. The degree to which we have reshaped the physical environment of this planet is greater than any previous species has ever managed. This cuts in multiple directions. The same capacities that have allowed us to understand the structure of atoms and the history of the universe have also, with far less wisdom and far less caution, allowed us to alter the chemistry of the atmosphere in ways that are beginning to produce changes in the climate at rates that the natural world has rarely experienced. the same drive to improve the material conditions of human life that has, within living memory, dramatically reduced the proportion of people living in extreme poverty, has also generated patterns of consumption and production that place stresses on the biological systems of this planet that took billions of years to develop. I mention these things not to send you into the night with a sense of dread, quite the opposite. I mention them because they are part of the story, because understanding where we are, honestly and clearly, is the necessary beginning of doing anything well. We are a species with extraordinary capacities. We have used them to understand things that our ancestors could not have imagined. We have built things that would seem miraculous to anyone from the past. And we are capable, genuinely capable, if we choose to bring our full capacities to bear, of navigating the challenges that those same capacities have helped to create. This is not guaranteed, but it is possible. And the history of life on Earth, which is a history of remarkable adaptation and resilience in the face of genuine catastrophe, gives at least some basis for a kind of cautious, clear-eyed hope. Section 17. What we are closing in now on the present, on you. Before we arrive there fully, I want to say something about what we are not as a species in general, but as the particular kind of thing that each individual human being is. You are made of atoms. This is simply true, and it's worth sitting with. Every part of you, your skin, your bones, the fluid in your cells, the proteins that do the work of keeping you alive, the ions that flow through your neurons when you think is made of atoms, hydrogen, oxygen, carbon, nitrogen, and many others in smaller quantities. These atoms have their own histories, as we discussed earlier in this story. Most of them have been many things before they became you. They have been part of the oceans. They have been part of other organisms living and dying long before you were born. They have cycled through the atmosphere. Some of them have been part of the earth, waiting for millions of years before being incorporated into a living thing again. For a brief period, the period of your life, they are organized in a very particular way, an extraordinarily complex, carefully maintained, precisely regulated way that constitutes a living human being. And during that period, this particular arrangement of ancient atoms is capable of something that the atoms alone in any other arrangement are not capable of experience. What you see, what you hear, what you feel, what you think, what you care about, and what you love, and what frightens you, and what fills you with wonder. All of this is happening because of the extraordinary complexity of the organization of these atoms, because your nervous system, your brain, your body, the whole elaborate system that you are, has developed the capacity to process information about the world in a way that gives rise to an inner life. We don't fully understand how this happens. The relationship between the physical processes in the brain and the felt quality of experience, why processing information feels like something rather than simply occurring without any inner experience attached, is one of the deepest unsolved questions in all of science and philosophy. Some of the smartest people who have ever lived have thought carefully about it for their entire careers, and the answer remains genuinely uncertain. What we know is that you have an inner life. You know this directly, immediately, incontrovertibly. Even if you can't fully explain it, you can't seriously doubt it. There is something it is like to be you right now, in this moment, listening to these words. That is one of the most certain and most remarkable facts in the universe. Section 18. The brief and precious span. Here is something I want to say gently, because it is important and because the gentleness of the late night seems like the right setting for it. Your life is brief. Not brief in a belittling sense, not brief in the sense of being insignificant or dismissible. Brief in the literal, factual sense. The span of a human life, measured against the time scales we've been exploring tonight, is something very close to nothing. A single breath in the enormous exhalation of cosmic time. And yet, and this is the part that matters, it is the only span of time that you will ever experience from the inside. The 13.8 billion years before you were born were not experienced by you. The billions of years that will follow your death will not be experienced by you. The particular window of time in which you exist and think and feel and love and notice things, that window is yours, and it is finite and it is real, and nothing that ever happens in all the time there is will take away the fact that you existed within it. There's a perspective, and I'm not saying it's the only perspective or even the right one, just one that I find worth offering, in which the brevity of life is not a diminishment, but the very thing that makes it precious. Not despite the fact that it ends, but partly because it ends. Because every experience you have is happening against the background of finitude, this day, this conversation, this particular quality of light or sound or feeling, and that background gives everything a weight, a texture, a significance that it might not have if there were always more time. The people you love will not be with you forever. The moments that matter will pass. The capacity to notice and appreciate and be moved by the world around you is something you have for a limited time, and then you won't have it anymore. I find that when I actually sit with it, not in a frightened way, but in a quiet, honest way, the way you can sometimes do at night when the usual noise of the day has settled, it is not primarily a source of sadness, though it can produce sadness. It is primarily a source of appreciation, a reminder to actually show up for the life that you have, rather than postponing it, rather than treating the present as mere transit to some future state in which the real living will begin. The real living is always now. It has always been now. It will always be now, until there is no more now. To have Section 19, what we owe to what came before. Let me say one more thing before we begin to close tonight's story. Everything that you are, every capacity you have, every piece of knowledge you hold, every skill, every intuition, every way of seeing the world came from somewhere, from someone, from some long chain of transmission and inheritance and teaching and learning that stretches back further than you can trace. The language you're hearing these words in that came from somewhere, from thousands of years of speakers, of writers, of conversations, of gradual change and evolution, each generation adding and subtracting and reshaping until the particular form of the language reached you. You didn't make it, you received it. The ideas in this story, where did they come from? From scientists and philosophers and storytellers and thinkers across centuries and cultures and continents, from the patient work of people who spent their lives trying to understand a particular piece of the universe and then shared what they found so that others could build on it. You didn't make those ideas, you inherited them. The body, you inhabit the product of billions of years of evolution, of life's long, patient experiment in form and function, of the particular lineage that connects you to every living thing that has ever existed. You didn't make it. You are it as the result of a process far older than you are. Even the thoughts you have, the ones that feel most uniquely, privately yours, were made possible by minds that came before yours, by parents and teachers and writers and strangers who shaped the way you see the world, whether you know it or not. None of this makes you less yourself. None of this diminishes the genuineness and reality of your own particular experience and perspective and inner life. But it does mean that who you are is, in some important sense, a gift from the long chain of everything that came before you, from the people who raised you and taught you, from the thinkers and builders and explorers who shaped the world you live in, from the billions of years of life that produced you, from the billions of years of stars and galaxies and cosmic evolution that produced the possibility of life. You are, in this sense, the current end of an almost unimaginably long gift giving. And what you do with it, how you live, what you create, what you care for, what you pass on becomes, in its turn, a gift to what comes after. Section 20, returning to the beginning. We began this story all those hours ago, across 3 evenings of slowly tracing the history of everything with a strange and difficult idea that there was no before the beginning, that time itself began with everything else in the same instant, and that there was nothing, no space, no time, no possibility before that instant. We began there, and then we walked forward through it all. The cooling of the early universe, the first light, the dark ages, the birth of stars, the formation of galaxies, the slow, quiet settling of our own particular corner of the universe into an ordinary solar system around an ordinary star. We watched a small planet cool and settle and fill with water. We watched life appear in that water, life so simple it barely counts as life by any intuitive measure, and yet already containing in its fundamental chemistry everything needed for everything that would come after. We watched life transform the planet, oxygenate the atmosphere, move from the water to the land, develop complexity and diversity, and eventually something like awareness. We watched the long, patient development of minds, first small, then larger still, then suddenly, by evolutionary standards, explosively larger and more complex, until something appeared that could do what you're doing right now. Lie in the dark and think about all of it. We've come all this way together, and we've arrived here at this exact moment, on this exact night, with whatever particular set of circumstances and thoughts and feelings you've brought to this evening. Whatever happened today, whatever you're carrying from the week, from the year, from the accumulated weight of your life so far, all of that, every bit of it is part of the same story we've been telling all along. The same story that began before time, that unfolded through billions of years of cosmic and biological and human history, that narrowed and narrowed through an almost unthinkable series of improbable events and lucky chances and patient processes to arrive at you. You are not a footnote to this story. You are not a small thing at the end of a large story. You are the story's most recent moment, the place where 13.8 billion years of becoming arrives right now and continues. Section 21, the quiet miracle of ordinary days. I want to say something about ordinary days before we close. Most of your life, most of anyone's life is not dramatic. It doesn't feel like 13.8 billion years of cosmic history culminating in anything in particular. It feels like waking up when you'd rather sleep, like the particular quality of light on a Tuesday afternoon, like the smell of something cooking or the way a familiar voice sounds on the phone, like the weight of small worries, the texture of routine, the unremarkable passage of hours. I think there's a tendency, when confronted with the enormous scale of the universe's history, the billions of years, the hundreds of billions of galaxies, the almost incomprehensible drama of it all, to feel that our ordinary days must, by comparison, be somehow insufficient, somehow smaller than they should be, given all it took to produce them. I don't think that's right. The ordinary days are not the consolation prize that comes after you've failed to live a dramatic and significant life. The ordinary days are life in its actual texture, in the form it actually takes for almost everyone who has ever lived. The extraordinary moments, the peak experiences, the decisive turning points, the occasions that make it into the stories we tell about our lives are embedded within the ordinary days, inseparable from them, made possible by them. The ordinary Tuesday afternoon is the universe experiencing itself. The familiar voice on the phone is the universe in conversation with itself. The weight of small worries is the universe caring about things, which is in itself one of the most remarkable things the universe has ever managed to do. Nothing about the ordinariness of these things makes them less real or less valuable or less deserving of your full presence. If anything, understanding the depth of the story that produced them, understanding what it took, how long it took, how improbable it was, might make it easier to appreciate them as what they actually are. Genuinely extraordinary things wearing the disguise of the ordinary. Section 22. What remains? There's a question that I think is lurking somewhere in the background of a story like this one, a question that a story about the immensity of the universe and the brevity of individual human lives almost inevitably raises, even if it's never directly asked. What remains? When a life ends, when the particular arrangement of atoms that constituted a person with their particular inner life and the particular experience of being in the world dissolves back into the broader world. What remains? I'm not going to pretend to give you a definitive answer to this question. It touches on matters that no one can claim to fully know, and I want to be honest about that. What I can say is some things that I think are true and that I find in their own quiet way meaningful. The atoms remain. This is simply physically true. The atoms that made you will continue in new arrangements, in other forms, cycling through the world the way they have always cycled. For as long as the world continues, they will be part of other things. They will be part of the earth, of the air, of the water, of other living things. They will not be you anymore, but they will not be nowhere. The effects remain. Everything you do, every conversation you have, every choice you make, every person you influence, every idea you share, every kindness you show creates ripples that continue after you. Most of them are impossible to trace, but they are real. The people whose lives you touch carry those touches forward, and they touch others. And the effects of a single life spread out through the social fabric of the human world become, over time, genuinely impossible to disentangle from the effects of everything else. The having happened remains. This is perhaps the strangest thing to say, but I think it is genuinely true. The fact that something occurred cannot be undone. The past is, in a certain sense, the most permanent thing. There is nothing that happens later can change the fact that something earlier happened. Your existence, the particular inner life you're living right now, the experience of being you, these are facts about the universe that will be true forever, in the sense that they will always have been true. The universe in which you existed is permanently different from a universe in which you didn't, and that difference cannot be erased. I find that thought that the having been is permanent, quietly comforting in the late night, in the way that things you can't fully explain can sometimes be comforting anyway. Section 23, the universe that cares. Here's something worth noticing near the end of this long story. For almost the entire history of the universe, the vast, cold, mostly empty expanse of space and time we've been exploring, nothing in it cared about anything. Not because caring is impossible, but simply because nothing capable of caring had yet come to exist. Stars didn't care about their own formation. galaxies didn't care about their own rotation. The processes that produced planets, that produced life, that produced minds, those processes didn't care in the way that we use the word about their own outcomes. And then, very recently, in one small corner of one ordinary galaxy, something happened that had, as far as we know, never happened before. Matter arranged itself in such a way that it began to care. You care about the people in your life, about things that matter to you, about the state of the world, about the people and creatures and places and ideas that have moved you, shaped you, become important to you for reasons that are sometimes clear and sometimes not. This caring is not separate from the physical universe. It is the physical universe at a particular level of complexity, doing something new, something that rocks and stars and gases cannot do, something that required billions of years of preparation, all those stars, all those planets, all that patient evolution to become possible. The universe that produced you is, through you, a universe that cares, that worries, that loves, that is moved by beauty and troubled by suffering and delighted by small, unexpected moments of grace. These capacities did not fall into the universe from outside. They grew from within it, from the same processes that made everything else. And they are as real and as natural and as genuinely part of the universe as anything else in it. I think this is worth knowing, not as a reason for pride. We haven't earned these capacities any more than we earned the atoms we're made of, but as a reason for appreciation. The fact that you're capable of caring, of feeling, of being moved. This is not something to take for granted. It is, on any honest reckoning of how improbable it is, something to be grateful for. Section 24. 13.8 billion years. Arriving at tonight, we are almost at the end of the story now, and I find myself wanting to do what we always do at the end of these long journeys. Arrive somewhere quiet. The universe is 13.8 billion years old. Your life, in comparison, is something like a single page in a book of many millions of pages, a single breath in a very long song, an almost infinitesimally small slice of the total story. And yet, and I keep returning to this because I think it's the thing that matters most, the whole story was necessary for this page. Every one of those billions of years, every star that formed and died, every galaxy that slowly rotated, every planet that settled into the right temperature for liquid water, every organism that lived and reproduced and passed its particular chemistry forward to the next generation, all of it was part of what was needed to produce this page. Not in a teleological sense, not because the universe was aiming at you, working toward you, intending you. The universe doesn't work that way. It doesn't aim or intend. It unfolds according to its laws, through its processes, and what arises from it is what arises. But you arose. That is what matters, and it matters entirely apart from whether it was intended. The fact that you arose from a process that didn't intend you is, if anything, more remarkable than if you had been deliberately made. It means that you emerged from the universe on its own terms, that the laws and processes of nature, left to their own devices over enough time, produced something like you. That's astonishing. It is genuinely, quietly, permanently astonishing. And tonight, right now, as you lie here and listen to these words moving through the air and into your ears and into your brain and becoming somehow meaning and feeling tonight, is one of the moments that all those billions of years were building toward. Not the only moment, not the most important moment, just a moment yours, real, happening, part of the story. The same story that began before time that produced light and darkness and stars and planets and oceans and life and minds, that produced everything you've ever known and everyone you've ever loved and every thought you've ever had. That story is still going. You are its current edge. And tonight, its current edge is lying down to rest, ready to close its eyes for a while, to let the body and the mind do the quiet, essential work of restoration and renewal that makes tomorrow possible. Section 25. A last thought before sleep. Before we close tonight, finally, gently, after this long journey, I want to leave you with something. Not a fact, not a number, something simpler. Wherever you are right now, the sky above you is full of stars. You may not be able to see them. There may be clouds or the light of a city washing out the dark or a roof between you and the sky. But they are there regardless. Hundreds of billions of stars in our galaxy alone. Beyond them, hundreds of billions of galaxies, each with their hundreds of billions of stars. An enormous, mostly empty, mostly dark, almost impossibly vast expanse of space and time, stretching in every direction with no center and no edge. And in the middle of all of that, not literally in the middle, since there isn't one, but in the middle in the sense that matters most, there's a small, blue, rocky world orbiting an ordinary star in one of the spiral arms of one average galaxy. And on that world, at this moment, there are roughly 8 billion people, each of them with their own inner life, their own particular experience of what it is to be alive, their own worries and loves and memories and hopes. And one of them is you, in whatever room you're in, at whatever hour, under whatever kind of night. One of the 8 billion, one of the most recent in the long, unbroken line stretching back to the first living things, one temporary, improbable, genuine awareness in a universe that is mostly unaware of itself, lying quietly in the dark, carrying within you the accumulated gifts of 13.8 billion years of becoming. You don't have to do anything with it right now. You don't have to make it mean something or resolve it into a lesson or carry it forward into action. Right now, the only thing you need to do is breathe and rest and let the long, patient universe do what it's been doing for all this time, continuing quietly in all directions while you sleep. The stars will still be there when you wake up. The story will still be going. And so gently will you sleep well tonight. And thank you truly for walking through all of this with me.